All right, now I'm going to show you how to do the lattice algorithm for multiplication. So we did the lattice method for addition, and basically what's happening here is we're going to have these little rectangles or squares, whatever you want to call them. They're going to be divided into diagonals. It's going to be your tens place and your ones place. That's how these little diagonals work. So when you add two single-digit numbers together, you're guaranteed to either get a single-digit or a double-digit number. Same thing when you multiply. If you multiply two single-digit numbers together, you are guaranteed a single digit that would sit in the ones place or a double-digit number that would sit in the tens and the ones place. So what we're going to do is we're going to like distribute basically, but we're doing this like in the shape of like a little, I don't know, it's almost like an array really. So what you're going to do, whatever you're multiplying, this is a 2-digit times a 2-digit number. It doesn't matter which number goes on the top and which goes on the side. That's completely irrelevant. I just put the first number on top, 14, and then I put the second number on the side. Now it does need to run down the right side, so I put 32. And it basically made 4 little squares. It's like a little 4-square grid. And then I drew diagonals in there. So I'm going to start with just like the top row, and I'm going to do 1 times 3, and then I'm going to do 4 times 3. And I'm going to put the results here where you have your tens place and your ones place. So 1 times 3, well that's just 3. That's just a single digit number, 3. So I put it in the ones place. 4 times 3 is 12. So see, you write it like that. That's how you write the 12 in the tens place and then the ones place. Now you notice you have a little blank triangle up here. If you want to put a 0 there, you can, or you can just leave it blank. Whatever makes you happy, okay? I'm going to put a 0 in there so nothing is left out. So we distributed the top row, right? 1 times 3, 4 times 3. Now we're going to distribute to the 2. 1 times 2, well that's 2. 4 times 2, that's 8. See how we're getting a single digit, so we put it in the bottom part. And again, just for consistency, I'll put zeros in there. And then what you do is you extend out your diagonals, and your answer is going to be the sum of these diagonals. So we have an 8 for this diagonal. We have 2, 0, and 2. That makes 4 if you add them up. And then 3 plus 1 is 4. So we end up getting 448 as a way that you multiply. Have you ever seen this? Probably not. Will you ever teach this? I don't know. Maybe. You might. Again, we're giving you lots of options to have in your tool bag. So if you have a student that absolutely cannot do the standard algorithm, this might be the way that they can overcome multiplication. And it works for any number of digits times any number of digits. So if you wanted to do a 2 by 3, you have to set up a rectangle, 2 by 3. Here we're going to do a 3 by 3. This would be a nightmare with the standard algorithm. Nobody wants to do that by hand with the standard algorithm, not even me, and I like math. So we're going to put 267 across the top, and I'll put 135 down the side. And what we're doing is breaking this problem down, it's a 3 by 3, into 9 little tiny easy multiplication problems. So 2 times 1, let's start with the first row. 2 times 1 is 2. 6 times 1 is 6. 7 times 1 is 7. Well, that was easy. And then, put zeros in here if you want for the blanks. Second row, 2 times 3 is 6. 6 times 3, oh, that's 18. 7 times 3, that's 21. Put a 0 over here. And now the last row, 2 times 5, that's 10. 6 times 5 is 30, and 7 times 5 is 35. See how quick it is? I mean, it's little small multiplication problems are easier than big ones. And then we just have to handle all the diagonals. I usually go from right to left. So it's your ones place, it's a 5. Then your next one, your tens place, you've got a 3 and a 1, that's a 4. Now look at this next diagonal, 7, 2, 8, and 3. Well, 7 and 3 make 10, and 8 and 2 make 10, so that's 20. So you put down the 0, but you have to carry the 2, and that 2 is going to get added into this next diagonal. 6, 1, 6, 1, and 2. So that's 7 and 7 and 2 more. So 14 and 2 more. That's 16. We have to carry the 1. And then in this final diagonal, we have a 2 and a 1 that makes a 3. So 36,045. If you don't believe me that this is easier than the standard algorithm, I encourage you to get a sheet of paper and try to multiply that out with the standard algorithm. I think breaking it down into 9 smaller problems is a little bit easier, but that's me. But you do see that even still some carrying has to happen when you carry from diagonal to diagonal. It's the ones place, then you've got your tens, hundreds, thousands, 10,000. So these diagonals are your place values. You just have to collect up all the numbers inside.